All right, this is a debrief on how to do right chemical reactions homework assignment for Chemistry CP. Here we go. The backside began with problem number 6 because we did the first 5 problems in class. Unfortunately, it looks like the audio that went with my video recording was not recorded, unfortunately. But on the homework, number 6, oxygen gas reacts with gaseous nitrogen dioxide to make gaseous dinitrogen pentoxide. Oxygen gas is O2. Reacts with, and yes, you could put gas in parentheses, gaseous nitrogen dioxide. So NO2 gas to make gaseous dinitrogen pentoxide gaseous. All right, so there is the skeletal equation written already. And that's all there is for number 6. I'm going to go and take the next step and try to, well, actually, that's all I'm going to do in this video. It's just write the skeletal equation. Oxygen gas reacts with gaseous nitrogen dioxide to make gaseous dinitrogen pentoxide. Clearly to you, this should be unbalanced because we only have 1 nitrogen on the left, 2 on the right, 4 oxygens on the left, 5 oxygens on the right. Number 7. Ammonium dichromate solid creates chromium 3 oxide solid nitrogen gas and dihydrogen monoxide liquid. All right, so first of all, ammonium is NH4 and it has a plus polyatomic charge, just kind of a memory. So on the reference sheet, list of common ions, polyatomic cations, ammonium is NH4 with a plus charge. Dichromate, go look it up. Dichromate has a 2 minus charge and is represented by Cr2O7. So by crisscross, I'm going to need 2 of these ammoniums for every dichromate Cr2O7s to make it a neutral molecule. The 2 minus charge becomes a 2 subscript. The 1 plus charge becomes an invisible subscript of 1 on this polyatomic molecule. So here is ammonium dichromate in parentheses subscript lowercase letter s for solid. Creates, so this decomposes, there's no other reactant. Chromium 3 oxide. So chromium is Cr, and by 3 it means a 3 plus charge. Oxygen, being what it is, a halogen, is always going to be a 2 minus charge. So by crisscross, we're going to need 2 chromiums for every 3 oxygens, and this will be in a solid state. Each chromium is a 3 plus, each oxygen is a 2 minus. 2 times -3 is -6, 3 times 2 is 6, 6 plus -6 add up to 0, it's a neutral molecule. Nitrogen gas. Nitrogen is one of the 7 diatomic molecules, so it's always going to be diatomic when you write it by itself, and it's a gas. And dihydrogen monoxide, you should recognize as just being water in the liquid state. That's number 7. Number 8, solid cobalt-3 bromide reacts with lead-4 arsenate solid to make solid cobalt-3 arsenate and solid lead-4 bromide. So cobalt, Roman numeral 3, is a 3 plus charge. Bromine, being the halogen that it is, by the way, I may have accidentally said that oxygen was a halogen. That would be a mistake. Oxygen is a chalcogen, and the halogens are the halogens. So my bad. Bromine is a halogen. It's always going to be a 1 minus charge. Cobalt is a 3 plus charge. So I'm going to need 3 bromines for every cobalt to make them neutral. Reacts with lead 4 arsenate. Lead is Pb. Roman numeral 4 means it has a +4 charge. Going to the list of common ions, polyatomic anions, looking up what is arsenate. Looking, arsenate is ASO4 with a 3- charge. So ASO4 has a 3- charge. The lead has a +4 charge. So we're going to have to do crisscross and use 3 leads for every 4 arsenates. And the way that works out, again, lead has a +4 charge, arsenate has a 3- charge. By crisscross, we're really doing 3 times +4 is +12 for the leads, and 3 times 4, I should say -3 times 4 is -12 for the arsenates, for the 4 arsenates put together. So the +12 cancels in -12, and we have a neutral molecule to make. And by the way, this is solid, so little subscript, lowercase letter s for solid. Solid, cobalt-3 arsenate. So cobalt, and again with the arsenate, ASO4 is arsenate. If you've already forgotten it, arsenate is a 3- charge. Cobalt with a Roman numeral 3 means it's a 3+ charge. So we only need 1 cobalt for every arsenate polyatomic ion. There's no need to have a subscript 3 and a subscript 3. Just COASO4 is cobalt-3 arsenate, and then a little subscript lowercase letter s for solid. And solid lead 4 bromide. So bromine being a true halogen, it's always going to be a 1- charge. Lead with a Roman numeral 4 means it's a +4 charge. So I'm going to need 4 bromines for every lead, and it is a solid substance. For the review questions, the density of gold is 19.32 grams per milliliter. A gold nugget has a mass of 8.75 ounces. Determine the volume of the gold nugget in units of cubic millimeters. So you have to do several conversions here to make this thing work out correctly. For starters, we begin with 8.75 ounces, which is a unit of weight on the surface of the Earth. And in a conversion table, everything written in the numerator is multiplied, everything written in the denominator is divided. So we should figure out, there's, of course, if you went online, you can pretty much directly convert from ounces to grams or ounces to kilograms. But not going online, looking up a table, we would say, first of all, well, there are 16 ounces in a pound. So 16 ounces down below, 1 pound written above, and there's no sig figs limitation here. These are precise definitions. So it's 1 infinitely precise, 1.000 to infinity. Pound is 16.000 ounces. So this will convert our ounces to pounds. Then, perhaps with the help of Lord Google, you could look up that, say, 454 grams is equivalent to 1 pound. And the abbreviation for pound is LB for some Latin reason. So this is 1 LB, 1 LB. Now the ounces will cancel, the pounds will cancel, and when we multiply 8.75 by 454 and divide it by 16, that will tell us how many grams we have. And I see I really have another unit here. It says, no, it doesn't. Okay. So this mass can now be converted to grams. Separately, we want to figure out the volume, knowing the density and its weight. It says here mass, but really ounces is weight. Of course, the formula is density is equal to mass divided by volume. So if we want to rearrange and determine the volume, we could multiply both sides by the volume, then divide both sides by the density, and what we have is volume is equal to mass divided by density. So in this first part of the conversion, we have converted ounces to grams. Now we really need to divide that by the density of gold. And it states here the density of gold is 19.32 grams per milliliter. We're dividing by that, which means invert and multiply. So the 19.32 grams go down below, meaning they will cancel, and the 1 milliliter will go in the numerator. So now our grams will cancel, and we do have a volume in milliliters. However, it's specified to put your answer in units of cubic millimeters. Reminder that a cubic centimeter is a milliliter. And in a linear dimension, 1 centimeter is 10 millimeters. You might accidentally think, therefore, that 10 cubic millimeters is 1 milliliter. But that only takes care of one of the three dimensions. You have to multiply the length times the width times the height. And so that means you have to take this conversion and cube it to get the proper conversion factor. So if I want to convert this from milliliters to cubic, from milliliters to cubic millimeters, I could, if you want, take that one little step that says 1 cubic centimeter is equal to 1 milliliter. That way the milliliters will cancel. But now you have to do this triple conversion here. This is okay. For every centimeter, I have a length of 10 millimeters. This will take care of, let's say, the length of it. This will take care of the width of it. This will take care of the height of it. And now you're ready to power up your calculator and determine the answer. With appropriate sound effects if your batteries are clear. So 8.75 divided by 16 times 454 divided by 19.32 times 10 cubed, enter. I'm going to pause. I put it 10 squared. I was confusing myself there. All right. So my calculator says 12,850.99638. Of course, that's too many significant figures. So rounding this to 3 sig figs, looking at the fourth place, rounding up because it's 5 or greater, we would say 12,900 cubic meters is the volume on this review problem. And finally, number 10. A car travels at a rate of 72 miles per hour. The car travels a distance of 4.2 times 10 to the fifth power feet. How long in minutes did the car travel, and how far did the car travel? The formula is the distance that you travel, or in this case, the displacement, is equal to your constant speed times time. We have miles, hours, feet, minutes. So we do need to do some conversions here. And one of the conversions we can do is take the 4.2 times 10 to the fifth power feet and turn that into miles, or we can take miles and turn it into feet. So let's take 4.2 times 10 to the fifth power feet. And this isn't, the only way to do it, right? You can go the other way. The conversion is that 1 mile corresponds to 5,280 feet, which you would get from a reference sheet. So 4.2 times 10 to the fifth power divided by 5280 is 79.54545454 miles. So that's the distance traveled. And the speed is 72 miles per hour. So to solve for the number of minutes, we could first calculate the number of hours that it takes to travel that distance. If we take the distance and divide it by the speed, that will tell us how much time it took to travel that distance. So if we go 79.5 miles and we divide that by 72 miles per hour, 1 divided by 1 divided by x is x. So 1 divided by 1 divided by hours is hours. The miles cancel. 1 over hours is hours. So we'll get an answer with the correct units. 79.5 divided by 72 is a value of 1.10 hours. Of course, we need to convert that into minutes, and most of you know that there are 60 minutes. Again, that's a precise definition in 1 hour, so we're not limited on sig figs in this definition. So if I multiply my calculator display by 60, it says this worked out to be 66.3 minutes. And how far did it travel in miles? Okay, so we really answered that question first. And the time in minutes was answered there. Ta-da! This ends this debrief.